Assalamualaikum and hi everyone. My name is Fakira Shafika binti Faizarul Hafiz and my matrix number is U2101197/2. In today's video, I will guide you on how to make a DIY FCC crystal at home. This is part of my solid state physics course assignment. First, I will explain the materials needed, the steps to make the FCC crystal, and the results. I will also share some basic knowledge about the atomic structure of sodium chloride, the crystallization process, solid state theory, and the role of energy minimization in crystal formation. To start, the materials you will need include a metal pot and stirring utensil, a transparent container, water, a petri dish, a measuring cup, a tissue paper, a clamp, a scoop, a dropper, and a non-iodized salt. For the procedure, firstly, 400 ml of water was heated until nearly boiling in a metal pot. Next, 160 grams of non-iodized sea salt were stirred gradually in the boiling water until most of it dissolves. The salt was heated until small white salt flakes appeared on the surface of the solution. After that, the solution was left to cool to room temperature. The solution was filtered and poured into a transparent container using a coffee filter, sealing it to stabilize for After a day, around 1 cm depth of the solution was poured into a petri dish and left it undisturbed for 1 to 2 days. Once dried, a seed crystal was selected and transferred carefully to a smaller petri dish using a clamp, and a small amount of the solution was dropped using the dropper and let it grow undisturbed for several days, weeks, until a month. Finally, once the crystal has grown, dry it on tissue paper. From this experiment, this is the result of my DIY face-centered cubic FCC crystal. The fundamental explanation of it starts with the atomic structure. Sodium chloride is a classic example of an ionic solid. Crystal lattice forms from sodium chloride is due to strong ionic bonds between sodium and chloride ions. The crystal structure results from strong electrostatic attractions between sodium and chloride ions that create a repeating three-dimensional pattern. In an FCC lattice of sodium chloride, each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. This cubic arrangement creates strong attraction between opposite charges, making the structure stable and energy efficient. The crystallization process has 3 main stages. First, saturation. When water dissolves salt, it reaches a point where it can no longer dissolve more and becomes a saturated solution. This happens because the water molecules can only surround and separate a finite number of sodium and chloride ions. Second, supersaturation. As water evaporates, the remaining solution holds more ions than it normally can and becomes supersaturated, leading to crystal nucleation. Thus, the ions tend to return to a solid state by attaching themselves to any available crystal surface, leading to crystal growth. Third, growth dynamic. The growth happens at the crystal surfaces and edges, where the ions attach to specific lattice positions, enhancing the crystal's cubic geometry. The solid state theory states that sodium chloride crystals typically form cubes due to the uniform arrangement of ions in an FCC lattice. This cubic symmetry arises from the equal-sized ions arranging in a pattern where each ion is surrounded by 6 of the opposite type. The salt crystals exhibit sharp edges and flat faces characteristic of their cubic nature. Real crystals often have imperfection. The impurities occur if other substances are present. They can disrupt the orderly growth of the lattice. For example, iodized salt or dirt particles can lead to irregularities in the crystal shape and slower growth. Crystallization occurs because the system tries to minimize its energy. The formation of a crystalline structure reduces the system's free energy as the lattice arranges into the most energetically favorable configuration. Each step in growth releases latent energy, making the process spontaneous. Thank you for watching this video. I hope it helps you learn something new about phase-scented qubit crystal. Don't forget to like, comment, share, and subscribe for more content.